So yeah, good afternoon, everybody. It's not working. Apart from being the last thing that separates us from the coffee break, I currently live and work in Pisa as a PhD student, and my work focuses on supporting application deployment and management through the fog computing paradigm and infrastructures. So before I start, please let me introduce a little bit of background on the fog. The current deployment models for IoT applications are either IoT plus edge deployment, which means that we have edge devices computing on IoT data, which translates into low latencies, but we have limited hardware capabilities that support our computation, and of course difficulties in sharing data among the devices. On the other hand, we have IoT plus cloud deployment, where the edge devices simply act as dumb gateway that stream data to the cloud for further processing, which translates into huge computer power availability at the cloud, but a requirement for mandatory connectivity, high latency to transport data from the edge to the cloud, which are not bearable when the application is latency sensitive or bandwidth angry, and the bandwidth bottleneck that our connection to the internet may represent. So these two deployment models are not sufficient to support the continuous amount of data that is produced by the IoT alone, and there's a need for filtering the data that we produce, aggregating it in the edge layer, and processing a little bit before the cloud. Where must be determined depending on the vertical that we analyze, and it depends on the QS constraints that we have on our application. So in between those two, fog computing has been proposed, and it's a model that distributes computing, storage, and control all through the continuum from the IoT to the cloud. And therefore, it enables a faster decision making and the better processing of these petabytes of data that we produce daily. And in this context, Cisco proposed a first tool that is FogDirector, which is a tool for managing fog apps from the release of the application through the deployment, the configuration, the start, the monitoring, the stop, the undeployment, and finally the retirement of an application. FogDirector can be used by an administrator and features both a graphical user interface and REST APIs. So we can write our Python program, for instance, that interact with the REST interface and manage our application. So let's consider a use case. We have a smart building application that manages the AC system, the heating system, a CCTV, and maybe also the lighting system of a building. It may be deployed in the common areas of the building, so for all the people that live there, but also per apartment, so for a single family in the building. And now we have Steve, our application administrator, that is in charge of deploying two instances, one for the whole building and the other one for a particular apartment, and to manage them sensibly. But Steve has two problems. The first one is that he's a new guy to FogDirector, and he must find a way to quickly understand its functioning and how it works, so to achieve a management which is correct and effective. And with the work we are proposing, we try to help him. How? A first solution to the first problem that he had is that, of course, he can read the manual, and he can start doing that, but he will soon find out that the manual is 160 pages of natural language, which may lead to some incomprehension, some difficulties in understanding how FogDirector works exactly, and it may be not the fastest and the quickest solution to understand FogDirector function. So we propose him to use operational semantics of the tool, which we wrote, and models all the basic functionalities of FogDirector in a compact and unambiguous way. So our semantics is 2 pages only. There's some formalism Steve should get acquainted with, but fine, 2 against the 160. So anatomy of a rule, this is how the rules of our semantics are made. So basically we have the monitored data about the infrastructure. FogDirector has monitoring capabilities for the nodes and the IoT devices that are connected in a fog deployment. And the data about the managed apps that may be just published or deployed or already running. And then we have the client that can perform operations up over parameters P1, Pk when condition C1, Ck, parameters, sorry, P1, Ps, when some condition hold. And finally, we have error code that tells whether the operation was successful and also when it was a failure. I will not enter in any detail of all the rules. We can discuss this at the poster session. And we go to the problem number 2. So write correct and effective management. If correct is easy once you have an operational semantics of the tool, because you can simply use the semantics to verify whether the operations that you're trying to issue to FogDirector are valid ones. Effectiveness should take into account a little bit more of information about the infrastructure, because resources at fog nodes may vary over time due to workload variations, but also communication links may be subject to variations in latency and bandwidth due to communication workload. And so we have to account somehow these. Well then, okay, we can mimic FogDirector, and this is what we've done. So we've taken our semantics, and we've implemented the core of a simulator in Python, which is FogDirMime, so that our app admin can simulate infrastructure management, application management, and monitoring and alerts of FogDirector by writing his own code and collecting data on the performance of his scripts. So the prototype is open source and it's available on GitHub if you're interested to download it. And this is the big picture. So we have our management scripts that can be many. We may want to test them before we put them in production. So actually, we can run an abstract representation of them in FogDirMime, but we still miss a little bit of a piece of the puzzle, which is the very network and QoS. And to do this, we can take aggregate data on the monitoring of the FogDirector instance that we're trying to manage, and we propose to use a probabilistic sampling of both latency and bandwidth of communication links end-to-end, and of the available resources, RAM, storage, CPUs, at each fog node available in the infrastructure. And so I'll go through a quick example. This is the smart building application we've seen before. We specify the hardware requirements, so 1 CPU, 2 GB of RAM. We also specify some requirements on how things should be accessed, on the QoS required to access things. So for instance, the fire alarm must be accessed with low enough latency. The video streaming must feature a latency which is suitable for streaming video, and so on and so forth. And on the other hand, we have the infrastructure that feature probabilistic hardware capabilities. So Fog1 has 2 available CPUs in 80% of the cases, but only 1 in 20% of the cases, for instance, and also links that may have variations according to those probability distribution. Every time we need to have information about this data about the infrastructure, we sample a different status. So Steve can write arbitrary simulation scripts exploiting FogDirector's APIs and collect data on the management that he has, both on the performance of the script. I mean, if the script is of the performance of the script against varying infrastructure, and on the correctness of the script. If the script is wrong, it will issue an error. He can run it and get the information he wants. So for instance, in this case, there are two deployments of the application. And the first one in here on top, when there are low resources at FOG2, where we deployed our app, moves the app to FOG3 for good. Whilst the second instance is toggled between FOG1 and FOG2 every time there is a problem in the available resources. And so we get results after simulating for 10,000 epochs this script. And we get that the first deployment doesn't reach the things, the IoT devices with the proper QoS in 20% of the cases, whilst the second deployment has a problem on resources in 16% of the time. If Steve is fine with this data, he's happy and he will deploy a script in production. Otherwise, he can fine-tune it or change some of the available nodes. So to conclude, we offered a concise and unambiguous reference that can be used to describe all basic operation of FogDirector, from publish to retirement of an application, passing through configuration and monitoring. And we enact the application manager to test beforehand, at design time, the correctness and the effectiveness of a script without having to test them in production environments. So validation, at design time, and performance prediction are the other two ingredients of our recipe. Future work with our MIME, which has the transition system in one hand and some probabilistic dices in the other, include, but are not limited to, describe other functionalities of FogDirector, for instance, the upgrade of applications, but also the fact that an application may be multi-component and so consist of more than one module. Consider the scaling of the components of the application, as well as osmotic computing paradigm in this context, which means that we can have more than one flavor for each component that may make out our application. Implement FogDirSim instead of FogDirMime, so a full-fledged simulator that allows you to estimate the key performance indicators which are formally defined, as well as to configure the simulation environment at your wish, instead of writing ad hoc scripts. And finally, study other recent tools such as Edge Foundry, which is a framework maintained by the Linux Foundation for the deployment of Edge IoT systems, and maybe include them in our prototype. Naturally, I'm available to take and answer questions during the poster session. Thank you for the attention.
Okay, thank you very much.
Yeah.
How did you ensure that your 2 pages of rules exactly describe what the FogDirector does?
That's a good question, actually. Sorry. We will have to double check with true deployment, but their formal description at least, this works. Then it does the check that the FogDirector would do as described in the manual. So, yeah.
Okay, thank you. Now we have a coffee break and we will start our next session 10 minutes later, right? So 5:10, okay? So you can enjoy your coffee. Thank you.